Hello, everyone. This is Charles Clinton with you today, and we're going to talk about our fourth video on biostatistics summary, which is on correlation. So, here you can find all my summary notes for this topic, but we will go one by one. We will go in a slide format for better comprehension, and don't hesitate to ask any questions in the comment section below. So you can see that in this article from Nature, there is a clear-cut distinction between three clear or different concepts, which are association, correlation, and causation. Okay, there is a little bit of confusion in medical literature. So if you go and read an article from Stanford, you might see that they are using association and correlation as the same, as meaning the same thing. While if you go read an article from Nature, you'll see that they will say that association is very different from correlation. Okay, so let's simplify this a little. First off, we start with association. Association just means that something has some sort of relationship with some other thing. So using a very general example, if you're in a small store and there's 10 different people in the store, and you see that one of these persons has a long nose and a small child also has a very long nose and pointy ears, and both of them share several characteristics. So you can right off the bat make an association. You can think they are associated. The question now is, does this older person, did this older person cause this younger person to exist? So is there a causative relationship? We don't know, because they're just walking around in different places of the store. You don't know, and they don't have a name tag with their last name, so you know if this person is father or mother to this child. But you can distinguish an association. So this association might be seen as a correlation depending on where you read it, in which textbook or resource. I would recommend that for simplicity, you see these two terms of association and correlation as the same thing. But I will explain that association is not a technical term, while correlation is a technical term. So every correlation is an association, but not all associations are correlations. Why is this? Because a correlation is usually thought of as a linear association. And what is a linear association? It occurs when you have variables that might represent continuity. So it is a little technical, yeah, I know. So for the sake of your exam and in general, if you're not a biostatistician, understand that association and correlation will be used interchangeably in many places, even in your exam. But you do have to understand that these two are very different from causation. Is that the father of this child? We don't know. Are they associated? Yeah, they seem associated. So, yeah, different terms. So, let's talk about some types of variables. We have independent variables. What does this mean? Okay, an independent variable is when you're tossing a coin. Does it make a difference for you to get a heads up if you toss that coin 100 times or if you toss it 1000 times? No, actually it doesn't, because it's an independent variable. The probability of it falling on one side or the other is 50% on each occasion. So what happens down the line is not affected by any of the different tossing or turns of the coin. That's an independent variable. So that's important for you to understand. Then we have other variables which are dependent variables. What is a dependent variable? It is, let's look at this example right here. So if you have a hand or a deck of cards and you are asked to take just one card out, just one red card out, what will happen with the probability of you getting in your next card extraction a black card? Well, the probability will be higher because you already took out of the deck a red card, so the probability of you getting a black card on your next try will be higher. What does this mean? That this is a form of dependent variable, because what happens down the line is affected by that initial change you just made. So in general, we'll be speaking about 4 different terms, which we already just mentioned them. There's just 2 synonyms. So we have the predictor factor, which is the same as saying the independent variable. And you have the outcome factor, which is the same as talking about the dependent variable. So let's give an example. In medicine, what are we interested? The independent variable will be sodium intake. And the dependent variable is basically the outcome. So what will happen? Which one will actually change with a change in sodium intake? Your systolic blood pressure. So there you can make a very nice graph that we'll see in a couple slides down. So here we have an example of a headline that a patient can bring us, or we can actually read everywhere in the internet, and every day we're reading phrases such as this one. For example, a new study states drinking 4 cups of coffee or more is associated with decreased skin cancer probability. And this is why many of our patients come to ask us, and they will come and ask, hey doctor, I only drink 2 cups of coffee. Should I increase my intake to 4 cups so my risk of cancer, skin cancer, decreases? So since you already saw this video right here, you will understand that association doesn't necessarily imply causation. So this association is interesting, yeah, but you have to determine if there's any causation in order for you to make any recommendation. You cannot make recommendations on a descriptive analysis, which this starts off as descriptive. So let's look at the next example. Here we have 2 different persons. We have the individual in the previous slide, and we have a new individual. Here we have the coffee consumption for each one of them, and here we have a new factor which I didn't speak about in the previous slide, which is sunlight. So what's the relationship? Well, if you are working in an office the whole day, will you drink more coffee than the surfer, which is out on the waves the whole day? Probably you'll drink more coffee because you'll have the coffee dispenser right there, and you'll have different stresses, and it will be easier for you to walk 5 steps and get to the coffee machine and all that. So the coffee in this case, yeah, it is associated with a decrease in skin cancer, but that's not what is causing the decrease in skin cancer. What is actually causing the decrease in skin cancer is less exposure to sunlight as compared to those who drink less coffee. Because if you drink less coffee, it is usually associated with you being more in the outdoors, more exposed to sunlight. That is why coffee would be a confounding factor. That's the name of it. So yeah, we go back to the saying, association does not imply causation. And this right here is another great example. This is another medical example of how we have confounding variables and how these two don't, the relationship isn't clear cut. So that's why we have to go and do all those different analysis and prospective studies, because here we have alcohol consumption and lung cancer. So initially we descriptively or observationally see that there's a relationship between these two, but we didn't take into account that smokers usually drink more and that smoking does effectively cause or increase the incidence of lung cancer. So once again here, alcohol was a confounding factor and smoking was actually, was also both were associated, both were correlated, but only this one was causative or had a causation with lung cancer. Okay, so when we're talking about correlation, we usually use it as a synonym to mention the Pearson correlation. Why is this? It is because in medicine, more than 90% of the correlations we see are based on Pearson correlations. And this is the mathematical formula they use to make the graphs we usually see in the different articles. So just know that when we are talking about correlation coefficient, we are usually talking about this Pearson correlation coefficient, and the graph that you will see next is usually based off from this one. So this is the graph that you can develop with the Pearson correlation coefficient. The correlation coefficient will just tell you how, let's see, if it's a positive correlation or if it's a negative correlation. So here we have different examples of large positive, medium positive, and here you have negative correlations. How do you know if it's a small, medium, or large correlation? You can know it based on the coefficient or the R. So when you see an R value of such and such, it's usually, no, it always goes between -1 and +1. So above 0, 0 to +1, you have a positive correlation, which is a line going upwards. When you have 0 to -1, you have a negative correlation, which is a line going downwards. Always, when you see these graphs, you have to take into account that the P, that it is statistically significant. Although most of these studies are descriptive in nature, you need to see this right here for you to assume that you can say that there's some sort of correlation, because if you don't have this, you can't even determine that there's a correlation. So we already know that statistical significance is a P less than or equal to 0.05 with a confidence interval of at least 95%. And that's something I'll talk about in a next video. Okay, is there any correlation here? Is the line going upwards or downwards? And diagonally, none of the two, right? You're just seeing a line straight here and a straight vertical line here. If you see horizontal or vertical, there is no correlation whatsoever, because remember that there are two variables. Here you have one and here you have the other. On one side you have the dependent factor, and on the other side you have the independent factor. What does this mean? That just one variable is changing in value because the other is staying right here on the y-axis without increasing or decreasing. Same happens here, just that we inverted it. Here in the x-axis there is no change, not even positive or negative, while you are actually changing values on the y-axis. So here there is no correlation whatsoever. And this is my memory aid for you, because this is very high yield and this will come up in exams, and this is the way I would recommend you learning this. So think about a love relationship. If you have a healthy loving relationship, it is a positive relationship. So a healthy relationship is equal to positive relationship is equal to positive correlation. And how do you think your relationship will go in time? It will go increasing. It will increase its value. And how much effort are you guys gonna put into this relationship? In a positive relationship, you both are struggling for the relationship to improve. So if you are both struggling, if I struggle more, you struggle more. You struggle with me. That's what happens in a positive correlation. But when you have a negative correlation such as this one, instead of growing, you are declining. You are declining into an inevitable breakup. And what happens in negative relationships? That usually one person is exerting 90% of the effort and the other person is exerting just 10%. So the variables are inversely proportional. Here, one is increasing and the other is decreasing. That's why you have a negative relationship. So on the y-axis you have a decrease, and on the x-axis you have an increase. That's what happens in negative relationships, and that's how you'll use this in the test to your advantage. And right here, there's weak to no correlation, because look at this line. It's almost horizontal and everything is very spread out. Okay, this is another important point, which is the coefficient of determination. This question is specifically from UWorld, and the question here is, according to the information provided, how much of the variability in plasma homocysteine levels is explained by folic acid intake? If you just read this question, you won't be able to get to the answer, because you'll be like, I don't know what to do from here. I just have these numbers, and what should I do with them? Okay, here is where you have to think about the coefficient of determination, which is basically just stating that the coefficient of determination is multiplying by itself the correlation coefficient. So 0.8 times itself is 0.64, which means that the variable, the outcome factor, is 64% dependent on the predictor outcome. That's what coefficient of determination will tell you for the exam as well. And if you're actually searching for causation, because that's what we want in medicine, and our patients also want to know if there's a real association, causative association, what we have to do first is look at the patterns. So first observe, or use these descriptive analysis, Pearson correlations. Okay, there's a correlation. And after that, you have to try to take out all these confounding factors. And the confounding factors will be taken out, making well established, prospective, randomized, controlled trials where you can control the variables and make everything, control every variable except the variable in question. And that's where you'll have your null hypothesis and your H1 hypothesis, and you'll actually find out if there's a causative, or if one variable is actually producing the other. And we might talk about this in another lecture, but I think it is pretty clear with what we've spoken already. And this is the bibliography. So if you want to take a look, I'll add this in the YouTube video, a link to every one of these different articles, and I'll be posting in the stories section a couple of practice questions so you can practice what you just learned. See you in the next one. Hope you liked it.